Okay, we are starting our third section on energy. This one is called using electricity. We're going to start by looking at electricity in your home. Now, first the electricity has to get there. So it'll be generated somewhere, it's transmitted through the grid, and 3 wires will eventually arrive at your home. And it could be overhead wires like this coming from a power pole and transformer, or it could be underground through a conduit. Now, 2 of the wires are going to be hot. One is going to be plus 120 volts, the other is minus 120, and one is neutral. So household circuits can be hooked up in such a way as to be 120 volts or 240. Most will be 120 volts outlets. Electrical devices that have to generate lots of heat will operate from 240, and that means we have to hook them up to these two, the 2 hot wires, because the difference between plus 120 and minus 120 is 240 volts. Now you think in your house, what might produce a lot of heat that's electrically powered, and that could be an electric clothes dryer or an electric stove. So they'll have special plugs and outlets. So we know electricity is produced in BC largely by hydroelectric dams through generators, and since it's generators, it makes alternating current, AC, forcing the electrons to move back and forth repeatedly. And they don't do so at 60 hertz. Now the wires that come into your home will go to the service entrance panel. And that service entrance panel will then distribute the electricity to the branch circuits in the house. And you will also likely have circuit breakers or fuses so you can control those circuits and protect them. Typically the service entrance panel will be near the electric meter, where meter readings used to be done by a meter reader but are now done remotely. Electrical hazards. Well, we have 2 primary ones we worry about here. One is circuit overload, the other is short circuit. Circuit overload means too many appliances are hooked up to the same circuit. Each device will have a power rating, and what happens is you add all their power ratings in this formula. The voltage typically 120. If this total power gets too big, strangely I represents current because physicists are a bit odd, but anyways, the current will become very big, and if it becomes too big, it can lead to a fire unless you switch the circuit off somehow. A short circuit goes back to grade 9. I, current, equals voltage divided by resistance. If you have bare wires touching and one of them is connected to a hot wire, you are going to have a flow of electricity. And because these wires are good conductors, your resistance becomes very small. So if we take our voltage, divide by a very small number, the current will become big, and if it becomes too big, we can get a fire. So we have things like circuit breakers and fuses to protect against fires when the current gets too big. It will involve a bimetallic strip, and in a future video, probably the next video, you'll be able to watch a demo of the bimetallic strip bending when it becomes too hot. That's something you may remember from grade 8. Anyways, one of the beauties of the bimetallic strip is it can be used again and again. So let's say you trip a circuit breaker, you first find and fix the problem, and then you can reset the circuit breaker once the bimetallic strip is cooled. Each circuit breaker will have a rating that tells you the maximum current, measured in amperes, that can pass through that circuit breaker before it will trip. So circuit breakers are found in the service panel. A fuse has the same function, but a big disadvantage is once it's blown, that means it's melted, it can't be reused. So instead of having a bimetallic strip that bends, it has a wire that melts. But the important thing is it does work like a circuit breaker and stop from getting too big a current, potentially having a fire. And with a fuse, since you have to replace it, you got to make sure you get a fuse with the right rating. So overall, much more convenient and cheaper to use a circuit breaker. That's probably a good place to stop. We'll pick up here in our next video.